So last week we used our distance formula and slope formulas and to help us prove that a quadrilateral was a parallelogram. All right. We're going to use the same, only now we're going to be a little bit more specific. We're going to look at whether or not it's just a parallelogram or a rectangle or a rhombus or a square. All right. And again, this is in the coordinate plane. So 2 steps. And yes, it does require a little bit more work. All right. Step 1, in order to classify, we have to check the congruency of all 4 sides. We need to know not just that opposite sides are congruent, but are all 4 of them now congruent. All right. So again, we're going to use the distance formula to discover that. The other thing we're going to do is actually check the diagonals. All right. We did not do that before, because different shapes, the diagonals have different properties. So again, we're going to use the distance formula to look at the length. Okay. So if we know all 4 sides are congruent and the diagonals are congruent, that's going to make it a square. If all 4 sides are congruent but the diagonals aren't, then it's a rhombus, and we can go through all of them. Okay. In fact, the cases here are written out for you so that when you are done doing your math, you can come back in and look. If it's just a regular parallelogram, all right, then all 4 sides won't be congruent, just the opposite ones will be. And the diagonals will not be. All right, so you're going to have that pair congruent and that one congruent, but not all 4. And the other thing that's going to happen then is that, and a lot more tick marks here, but the diagonals will not be congruent either. Okay. With a rectangle, you will get opposite sides to be congruent, not all 4, but your diagonals will then end up being congruent to each other. All right, so you will have those that equal to that. A rhombus, you're going to get all 4 sides congruent, but the diagonals won't be. So that length will be different from that length. And lastly, squares, we know all 4 sides will be congruent, but then you will also get the diagonals to be congruent as well. All right, so a lot of distance formula, but we got to check it out. We're just going to do one problem together and then identify what type of quadrilateral it is. Now again, as we learn about different shapes, then things we need to do to prove will change also. So we are sticking specifically to just these 4 shapes, which is why we just need to check the sides and diagonals. Okay. All right, so we've got PQRS. So again, let's draw a picture because we have to know which sides are opposite and which are the diagonals. All right, so let's start with the sides, and I'm going to write them down as opposite sides. So I need to do PQ and its opposite side SR. Okay, then we're going to do PS and side QR. We're going to do those 4 distances. And then the last things I need to check are the diagonals. All right, which would be side, or say segment, not side, PR, and then QS. All right, so just to kind of, so these are my sides, these 2 are my diagonals. All right, so let's get going. So PQ, so we subtract the x's, so I've got -2 minus a -2, again becomes a +2. Plus, subtract the y, so 3 minus a -4 becomes 3 plus 4. So I've got 0 squared plus 7 squared. all right, which is just going to be the square root of 49. Now that's perfect, so we are going to take that all the way down to 7. All right, S and R. So I've got 2 minus 2, square that, plus negative 4 minus 3, square that. So again, we get 0 squared. Oops, I want to, excuse me, I want to keep parentheses around the number before I square it. And the reason I do that, even when it's positive, is just so I don't get in a bad habit. Because I got to remember, if I don't have parentheses around a negative and you try to type that in your calculator, that way it will be wrong. All right, so I've got that pair. Those are definitely congruent. Let's try PS. So I've got negative 2 minus 2 to square, and then 3 minus 3. So negative 4 and a 0 both need to get squared. So that will give me the square root of 16, which is just 4. And then QR, again, we've got negative 2 minus 2 to square, and then negative 4 minus a negative 4, which is really a plus 4. So again, we've got negative 4 squared plus 0 squared, which will give me the square root of 16, or 4. All right, so what this has proven is that my opposite sides are congruent, which you should get, but they're not all 4 congruent. All right, so I've kind of narrowed it down at this point to either, this is just either a parallelogram or a rectangle. Those are the two shapes that have opposite sides congruent, all right, but not all 4. So let's check out the diagonals. All right, so segment PR. P to R is the first and third points. So I'm going to do the square root of negative 2 minus 2, square that, plus, and then I'm going to do 3 minus a negative 4, which gives me 3 plus 4. So we've got negative 4 that we need to square and a 7. So 16 plus 49 is going to give me the square root of 65. All right, and then QS are the second and fourth points. So subtract the x's. I've got negative 2 minus 2 again, plus, and then I'll have negative 4 minus 3. All right, so it looks like we've got negative 4 squared and negative 7 squared, but again, both of those turn positive, so we will end up with the square root of 65. All right, so we've got opposite sides congruent, and we have the diagonals congruent. So I can cross off parallelogram because the diagonals are not congruent in that. So this is a rectangle. All right, now you're going to just explain what you just proved. So PQRS is a rectangle because opposite sides are congruent and the diagonals are congruent. That's what we proved. So this is the work that you should have for every problem. 4 sides, 2 diagonals, and then take a look and see what you ended up with. All right, let me know if you need some help.